Hello, Wayland Middle School's Mr. Farley here, and going to continue the videos on writing equations of lines. So we left off with number 4, so let's pick up with number 5 today. So have your pencil out, take careful notes as we go, and the first couple will be really fast as we get this going. So number 5, we're looking at a vertical line and a point. So your job is to find the equation of a line with no slope. That's something important, no slope, and it passes through the point -3 comma 4. Now, we've talked a little bit about this in class where we said, how in the world can you write something in slope-intercept form if it has no slope? So that should be a giveaway that we're talking about a vertical line here. All right, so no slope means a slope which is undefined, which means vertical line. And if it has to pass through this point, -3, 4, remember -3 is your x coordinate and 4 is your y coordinate. And what's important to know is if it's an equation of a vertical line, we would simply say x equals -3 would be the equation of that line. That's all you need to do for vertical lines. Vertical lines, it happens to be x equals. So we talked a little bit about that, and that's a good start right there. So let's keep going. We'll go to the next one. Here we go, number 6. This one's a horizontal line that passes through the point -1, -3. Now, if you think about this one, it's a horizontal line. Every horizontal line in the world has a slope of 0. So I guess if you wanted to, you could write the equation y equals mx plus b. I'm sorry about this pen that I'm using here. It's a pain. So y equals mx plus b. And in this case, b is going to be 0. So because of that, I'm sorry, in this case, m, the slope, is going to be 0. So it really wipes out this whole term right here. And y is going to equal b. Well, if I plug in my value of y right here, which is -3, that tells me that b, the y-intercept, has a value of -3. So that equation is simply y equals -3. And that is what we're looking for horizontal lines. Not too bad. Let's try the next one, number 7. So continue and keep on taking close notes and we'll be okay. So number 7, your job is to write any equation you want in slope-intercept form, which is parallel to this line. Now we've talked about this too. If lines are parallel to each other, they are going to have the same slope. And according to this equation right here, the slope is -5. So I am going to build any equation in the entire world that has a slope of -5. So here it comes. Here is y equals -5x. Now this line right here is parallel to this original one because their slopes are the same and their y-intercepts are different. The y-intercept has to be different for parallel lines. And if I do this here, I can add or subtract any value I want from this term. You can just make it up, whatever you want. The only thing is it can't be 9. If it's 9, then you have the same exact equation, so a line can't be parallel to itself. So we are going to just maybe add 3 or whatever you want. You can add any value you want except for 9. So there's that one. Moving right along. Let's try number 8. This one's a little harder, and I just want you to think about it. What you need to do is, again, we're looking for a line that is parallel, and it has to pass through this point right here. This time I can't say the slope is 2 because this equation is not in slope-intercept form. The y is not by itself. So you need to divide both sides by 3 to make sure that we get this in slope-intercept form. I've said it a million times. This goes to both. Don't forget, goes to both. And by doing that, I find out that my slope has to be 2/3. All right, you can see that. So now you're going to do just what you did yesterday. You're going to plug in and create a new equation. So y is equal to the slope, which is 2/3. All right, 2/3. And then don't forget your x, and then plus b. Now all you need to do is plug in the values of x and y. So here's the deal. X will be plugged in here, all right? And y will be plugged in right here. So if I do that, I get 5 is equal to 2/3 times 3. All right, 2/3. I'm plugging in 3. We know 2/3 times 3 is 2. And then I'm going to add my b to that, plus b. And when I solve it by subtracting, I get b is equal to 3. There you have it. So b is 3. Now I have my slope, I have my y-intercept, so I have my equation. Equation is y equals 2/3 x plus 3. I'm trying to write this as quickly as I can. Using a mouse pad is not easy, but hopefully it's working out for you. All right, so that's number 8. That was a good one. Let's try 9 and 10, and then we'll call it, which will be pretty good. This one's a little harder, okay? This one here, I want a line that is perpendicular. So we talked about lines that are perpendicular. Their slopes are opposite reciprocals of each other. And sadly, this time I can't say that the slope is negative 1/2. What I need to do is get this in slope-intercept form first. So I'm going to just kind of do this in my head, and I'd like you to follow along just so I don't have to write with this mouse pad. So I'm going to be adding 1/2 x to the other side and then dividing by 4 to get the y by itself. And if I do that, I find out that my slope is 1/8. All right, I think everyone can follow that. If we're adding a half, 1/2 x over here divided by 4, I get 1/8. And now I just want to write an equation of line that is perpendicular to this one. If this line has a slope of 1/8, I know that my new line, the one that is perpendicular, will have a slope that is the opposite reciprocal. And the opposite reciprocal of 1/8 is -8. So I'm just going to say negative 1/8 x. And that's a fine equation. This equation right here is perpendicular to this one. It means they intersect at 90 degrees. The one thing that you can do, you can add or subtract any number you want to this equation. And just for today, I'm going to do plus 5. You could add or subtract anything you want, and it will still make these lines perpendicular because their slopes are opposite reciprocals of each other. And finally, the last one, number 10, this one's a little bit harder, but still the same ideas. If it's going to be perpendicular, and it has to pass through this point, remember we need a slope that is the opposite reciprocal of this. And good news for us, this is already written in slope-intercept form. So we know that the new line that we're going to build is going to have a slope that is the opposite reciprocal of negative 4/5, which is positive 5/4. So put that into your equation with the x and the plus b. So this is looking like slope-intercept form. This time we just can't randomly pick a value for b, the y-intercept, because this point has to go through this point. I'm sorry, this line has to go through this point, -8, comma 3. And with that, I'm just going to plug in this point like I've done a million times. Y turns into 3, x is going to turn into -8, and I'm going to just plug that in for you right now so you can follow along. All right, I'm almost done with this mouse pad. All right, there it is, plus b. And when I calculate this, I get -40 over 4, which is -10. So 3 is equal to a -10 plus b. What I'm going to do is add 10 to both sides. And if I do that, I find out that b, which represents the y-intercept, is going to equal 13. So now once I know that, fortunately for me, I now know the y-intercept and I know the slope. And if that's the case, I put those two pieces together and I create the equation y equals 5/4 x, all right, 5/4 x plus 13. So I hope this was helpful. I hope you took careful notes on your note sheet. Once you did that, please make sure you continue with the practice problems that were assigned, and hopefully I will be back in school tomorrow. Hope all's well, and, if you have questions, check in with your table partners, and, that's it. Hope you enjoyed this award-winning video. Take care.